Hello Math 13-14 students. Let's begin Lesson 3, Systems of Equations and Inequalities. Let's begin with the simplest types of systems, that is, systems of linear equations with two variables. Two equations, two variables, both are linear, just first degree, no second degree or higher or anything transcendental. One way to solve this kind of system is to use so-called the method of substitution. That is, find the simplest variable to solve for that variable, and substitute it into the other equation. That's the way to go. Now, what's the simplest? What do you want to solve for? I hope everybody made the same decision. This one here, which I just highlighted in blue, that's the simplest by far. Compare with 2x or 3y or 4y. That's the simplest. So let us solve with respect to x from the second line, and then we're going to substitute it into the first line. Okay, let's go ahead and do that. X plus 4y equals -1. So x is -4y minus 1. So flip the sign, and we're ready. It's done. So I'm going to substitute it into the other equation. Not back to this. If I do it back to the second line, then I'm going to get something like 0 equal to 0 or -1 equal to -1. I get nothing. You have to put it into the other equation. So we have 2x plus 3y equals to 6, right? But then again, this x is, as a matter of fact, -4y minus 1. So this x, highlighting in blue, becomes that. Now what do you have? We have just one equation with parentheses, just linear equations, so it's easy. Break up the parentheses, take the like terms, and the final division, you're going to get your y value. So how do you do that? Well, you can try. Stop the playback and try. Did you get the right answer? If you did right, you're supposed to get -8/5. Did you get -8/5? Don't just watch. Stop and do some work of your own. So okay, we got an answer, which I'm highlighting in different color. Let's use red, alright. And then let's put this red into any of those equations here. First equation here is okay, I can use that. Or the second equation here, I can use that too. But I prefer to use this equation, the third equation, which came from the second equation, but it is already solved with respect to x. So plugging y value into this one is the easiest. So x is -4, but instead of y, I have to put in -8/5 and then -1. Doing this computation, it shouldn't be too hard. You can just use calculator. If you do it, what do you get? 32/5 and then -1, so which is 5/5. So 32 minus 5, you're gonna get 27. So you're gonna get x is 27/5. Let me highlight it in green. So the answer, x is 27/5 as highlighted in green, and y is -8/5 as highlighted in red. And the intermediate step here, solving for one variable and substituting it to the other, well, that too is highlighted, and I use blue for that. That is a key part. Solve for one variable and substitute it into the other equation. This kind of method is called the method of substitution. Shall I do a practice? Okay, let's go ahead and do a practice. Go to an example problem here and select the problem and then do it. Let's see, what would you like to do? To me, this is too simple. We have just ln y here, so that's not good enough. You can try. I'll completely leave that to you, but for us, let's do a little bit more higher level. Let's do this one. So there's no ln x or ln y, so you have to select the simplest and then solve for that. Which is the simplest? Well, 2x here is a candidate, that's simple. 2y here is also a candidate, that too is simple. Which one would you like? Let's solve for 2x. That's the simplest, alright. 2x plus 4y equals to 3. From here, let's solve for 2x. 2x is negative 4y plus 3. And then divide by 2, so negative 4y plus 3, or equivalently 3 minus 4y. Yeah, let's write like that. And then divide by 2. Okay, I highlighted that in blue. And we're going to substitute it into the other equation. We did all this from the second equation here. I had to put it to the first equation. Negative 3x plus 2y equals to negative 1. Here, in place of x, I'm plugging in 3 minus 4y over 2. Make sense? 3 minus 4y over 2. Solving that, okay, alright, we have denominators to remove and then some parentheses to break. Multiply by 2 to everything, you're gonna get negative 3 and then 3 minus 4y, and then multiply by 2, so 4y, multiply by 2, so negative 2, that's what I'm gonna get. And then, okay, no more denominator, now break up the parentheses. So negative 9 plus 12y plus 4y equals negative 2. How's that? Distributing negative 3, so I have to have sign change to both. So take the like terms together, we get 16y, and then flip this negative 9 to the other side, so positive 9. So y is 7/16. How's that? Okay, we got it. So put it into any of those equations, and yeah, this is easiest. It's already solved with respect to x, so let's go ahead and solve that. X is 3 minus 4 times 7/16. And then, oh, okay, and then I forgot dividing by 2. Too complicated? Okay, alright. Let me use division by 2 like this. Well, you can use calculator for that. I mean, yeah, multiply by 16 and no, I don't think it's worth our time. So let me use computer algebra system for that kind of computation. Turns out we have 5/8. Okay, alright, we have the answers. X is 5/8 and y is 7/16. What did I do in my answer key here, by the way? So for y from the first equation, oh, here I decided to solve for y instead of solving for x. Okay, alright. 2y, 2x, they're pushed. They're equally as simple. So solving for y, we get this fraction, 3x minus 1 divided by 2. And then substitute it to the second equation. You have to do it to the other equation. And then remove the denominator by multiplying 2 to everything. And then break up the parentheses, take the like terms together, simplify. Eventually I'm getting 5/8. Okay, alright, that was easy. And then find y. Just put in 5/8 right here in place of x, and then run your calculator. Same answer as expected, 7/16. Want to do one more substitution? How about this? Any idea? We have decimals flying around, but don't be intimidated. My first suggestion is to simplify by moving the decimal 2 spaces. We have 2 decimal digits, just one here, so 2 is the most. So if I move twice, that's going to kill off all the decimals. That's equivalent to multiplying by 100. So multiply by 100, move twice, so we have 70. Multiply by 100, move twice, we have 15. Multiply 100, 2 more zeros. Okay, we have now a new system which is equivalent to the previous. I'm still not completely satisfied. Looks like I can simplify this thing better. Divide each by 5. So divide by 5, 70 divided by 5 is 14. Divide by 5, I get 3. And divide by 5, what do you get? Multiply 2 and divide it by 10. So this is 48, and remove 1 0 here. I'm pretty sure I did it right. Yes, I did it right. Okay, alright. That's better. And here, please go ahead and use your favorite method. If you want to use method of substitution, then clearly you're going to solve for x from the second equation and substitute it to the first, and so on and so forth. Good luck about that. Let's see. Did you get it? If you haven't started, then stop the playback and try. What did you get? If you do it right, you're supposed to get 264 and 368 respectively in the end. Do we have a full solution? Oh, I don't have full solution here. Just a setup and the final answer. So the full solution is completely left to you. Some simplification, yeah, as I suggested to you. And then you can use the substitution method. If you do not like substitution, you can use elimination, but that's something I'm going to talk about in a second video. And then we have an equation with, we have a system with 3 equations and 3 unknown variables. Let's talk about it in a separate video, probably in the 3rd video, or maybe an optional video toward the end of section 1. Okay, alright. I guess we completed the method of substitution.